So today we are talking about reflections. This is really the last thing I have to show you graphing wise. We're going to do some other types of notes, but this is about as difficult as it's going to get. I actually personally love reflections. I think they're kind of fun. Cause you to think a little bit differently, but they're honestly not bad. Before we do an example, let's talk about what a reflection does to the graph. And if you remember anything about reflections, you're going to be able to follow this train of thought pretty easily. So let's compare the sine and the cosine graphs. So the sine graph, and just like before, I'm just doing that very basic drawing, nothing complicated here. Sine starts at its origin, and if we have 4 intervals, it goes up to its maximum, to the midline, down to its minimum, back up to the midline. Creating that S shape we've talked about. So this is the general sine graph, no reflection. Let's graph it again, but with a reflection. The only point that doesn't change here are the points on the midline, so the point that we start with. Reflection, we're going to flip it over the x-axis. So all of those points, the maxes and the mins, they're going to switch places. So when we start, instead of going up to the maximum, we're going to go down to the minimum first. Then we go back up to the midline. Then we go to the maximum, back down to the midline. And then the pattern just continues from there. The changes you can see is quite minimal. You just have to pay attention, that's really it. Just make sure you notice that there's a reflection there so that you account for it. Let's do the same thing to the cosine graph. Same thing, we'll start with the general graph, what it looks like without a reflection. Cosine starts at its maximum, then down to the midline, then down to the minimum, back up to the midline, back up to its maximum. And then we create its U shape. Now for the reflected graph. So this graph will have a reflection. And once again, just to clarify, these are all going to be x-axis reflections. We're not going to do y-axis reflections in here. So again, the maxes and mins are going to flip. So instead of starting at the maximum, we're actually going to start at the minimum for cosine. Then up to the midline, then up to the maximum, back down to the midline, back down to the minimum, creating an upside down U. Questions on the basics of the reflection? Okay, let's do 2 examples. And when I draw my basic curve, when I go into each problem, I'm going to draw the reflected one. I think that'll be a little more straightforward because, again, the whole point of me drawing these at the beginning of my problem is just so I already have my visual and I don't have to think about how to graph it when I actually have to graph it. Just makes my life a little easier. First example, we are going to go very easy. Y equals -3 cosine of x. And let's make our list. Amplitude, period, interval, phase shift, vertical shift, and domain and range. What in that equation tells you there's a reflection? Yeah? The negative. Yeah. This is your dead giveaway. You see a negative in front, you have a reflection. A is negative. So that means we have a reflection. And again, if we're getting specific, it's an x-axis reflection. We will not be covering y-axis reflection, so you don't have to worry about remembering which is which. Just know that's what it is. So that is how you know. You should notice it immediately. Let's jot down the general information. General equation, y equals a cosine of bx plus c plus d. And I'll draw my general graph. So I've already noted that there is a reflection. And cosine, we're going for a U curve. Again, since this reflection is going to affect the placement of about half of the points, I'm going to go ahead and note that in my mini drawing. So we're actually, instead of starting at the max like cosine normally does, we're going to start at the min. First interval is on the midline. Second interval is at the maximum. Third interval back on the midline. Fourth interval back at the minimum. So this is what I'm going for when I make my graph. Let's go through the info. Our equation is not super complicated, so we're going to have a lot of standard answers here. Amplitude, is it +3 or -3? It's positive. You remember from when we first showed you that absolute value of A didn't seem necessary because all of our A's were positive. Well, this is why. When we get reflections, we kind of forget that rule and we'll put -3. It has to be positive. So absolute value of A is the absolute value of -3, which we know is 3. So even if there's a negative on there, only write the positive value. Period, 2 pi over b. And b here is just 1, so it's the standard 2 pi over 1, or 2 pi. Interval, period over 4. Two pi over 4 reduces to pi over 2. Phase shift, if we were to put what's in parentheses equal to 0, we would get x equals 0. So that just means that there is no phase shift. So you'd write none. Or x equals 0 is fine too. Vertical shift, that's your d value at the end. We don't have one. Got a little bit ahead of myself. There we go. D equals 0. So again, there's no vertical shift here. Domain, always the infinities, negative to positive infinity. Range will be determined after I have graphed the equation. Questions over the information? Okay, let's make a graph. And y-axis wise, we're going up and down 3, so make sure you give yourself enough vertical space there. As always, we'll have our 4 intervals to the left and the right. I'll go and label my y-axis numbers. For the x-axis, our intervals are pi over 2. So the first interval there is pi over 2. Per usual, I will do the unreduced fractions at the bottom and then reduce them above. We have 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2, giving us pi over 2, pi, 3 pi over 2, 2 pi. And the same for the negatives. Graph is set up. Let's start graphing. Starting point. I think this is the first equation I've done with you where there is no phase shift or vertical shift. So this time we are starting at the origin like we're technically supposed to. No shifts. From here, we're going to follow the pattern. We're starting at the minimum, and the amplitude is 3. So our minimum here is down 3. We're starting at -3. Next interval to the right, we're at the midline. Second interval, we're up at the maximum, which is at +3. Third interval, we're back down at the midline. Fourth interval, we are back down at the minimum of -3. there's half of our graph, the right half. And let's go to the left and finish it off. Again, cosine truly mirrors itself, so we're going to do the exact same pattern on the left side of the graph. We're going to go back up to the midline for the first interval, up to the maximum for the second interval, back down to the midline for the third interval, and back down to the minimum for the fourth interval. And sketch our curve. Arrange the graph bounces from -3 to +3 on the y-axis. So -3 to 3. Questions on example number 1. Okay, we'll do one more. We'll add all the bells and whistles to this equation. Second example, y equals negative sine of x plus pi plus 1. Our usual list: amplitude, period, interval, phase shift, vertical shift, and domain and range. General information, we'll start with the general equation. Y equals a sine of bx plus c plus d. Again, you want to pay very close attention. Notice that negative from the beginning. We have a reflection here. So when I make my mini graph, sine will still start at the origin, like it always does, at the starting point. But then instead of going up immediately, it's going to go down to its minimum first. Then up to the midline, then up to its maximum, back down to the midline. One way of thinking about this that always helps you remember is, since it's negative, we're going to go down to the minimum first on both graphs instead of visiting the maximum. So sine, after we start with the origin, the first place we go is the minimum instead of the max. And then the cosine, we start at the minimum instead of the max. Let's go through the info. Amplitude, reminder, it's the absolute value of A. That's a lot more important now that we're talking about negative A's. So we're still going to write, there would be a 1 here. So our A is +1. Do not write -1, it will be wrong. Period, 2 pi over b. And b here is still 1. So 2 pi over 1, which is just 2 pi. Interval, period over 4. 2 pi over 4, which reduces to pi over 2. Phase shift, you put what's in parentheses equal to 0 and solve. I'll show the little bit of work that is required here. That's x plus pi equal to 0. I'm sure the majority of you are comfortable doing this in your head. That's fine. Just be very aware when there is a number in front of x. It's an easy detail to miss. And that's going to change your answer. Subtract pi over x is negative pi. That is our phase shift. Vertical shift, that is at the end of the equation. We have a plus 1 there. Domain, always the infinities. Range will be determined later. Let's set up our graph, and thinking y-axis wise, we're going up 1 and then up and down 1 from there because of the amplitude. So you won't need a ton of space on the y-axis. So again, we're going up 1 and then another 1 for the amplitude. So 2 on the y-axis going up. I'll match it on the bottom, but I won't be using both of these. And our 4 intervals on the x-axis. The intervals on the x-axis are the exact same as the previous problem, so I'm just going to go through those real quick. We have pi over 2, pi, 3 pi over 2, 2 pi, and the negatives. Let's figure out our starting point. Let's look at our shifts. We're going to negative pi on the x-axis, so left pi, and then up 1. So negative pi up 1, starting right there. Going to draw a vertical and horizontal line through this circle. Vertical line represents my phase shift of x equals negative pi. Horizontal line represents my vertical shift of plus 1. From here, we graph our points. Again, this is why I make the drawing, so by the time I get here, I don't have to think too hard about it. I'm starting inside the circle. Then I go down to the minimum, and we're only going up and down 1. So our minimum here is at 0 on the x-axis. Next interval, we're back up to that midline, vertical shift line. Next interval, we're up to our maximum, which is up 1, so up to number 2. And then we'll go back down. Midline for the next interval, minimum for the next interval, midline for the last interval. I'm going to start my curve here. Going to the left, I only got 2 more points to plot. Remember, sine is not a mirror. You have to follow the pattern. So going to the right, I went down. So going left, I'm going to go up. We're doing it backwards. up to the maximum, back down to the midline. Range, the curve bounces from 0 to 2 on the y-axis, so that is my range, 0 to 2.